So today we'll see how to model a propeller hub assembly. The important part in this assembly is the propeller itself. Okay, so you must be very cautious while designing this. And for the coordinates, your question paper will be given coordinates like this. So you will write this on an Excel sheet and then save it as one main coordinate system. And using this coordinate system, you'll design your all other airfoils at different sections of your propeller. So let's start with that. So take your Excel. And also this is a simpler coordinate system. It doesn't have elaborate points. So the more points, the more the better design. Okay, so the one I've sent you has got many points. You practice in it, but this is how you will be doing it in your exam. 1, 0.95, 0.8, 0.6, 0.4, 0.25, 0.15, 0.075, 0.025 and 0, and then repeat 0.025, 0.075, 0.15, 0.25 and 0.4, 0.6, 0.8, 0.95 and 1. Okay, so these are the points in your x-axis. Now this is your y-axis. You don't have any points in y-axis, so just mark everything as 0. Delete this. And here in your z-axis you have got 0.0013, 0.0114, 0.0375, 0.0636, 0.078, 0.0767, 0.0661, 0.0496, 0.02990 and so on. So just to show you how this works, I'll just save one, go to save as, and the browser wherever you want to save. So I'll save it here, main coordinates. Okay, I'll just quickly show you how you can import that. Now go to solid edge, new part, metric part, and then you can come to your surfacing, curve on table. Here in key point curve on table, browse, and then import your coordinates. Okay, so once you come to your front view, your airfoil is generated, but there is one mistake in the problem itself. That is, wait, I just want to give you one quick review. Your first point is, or you might be wondering where your points are. So your point 0, 0 is here. So the first point 0, 0 will start here, and then as you move, okay, 0.025, 0.75, 0.15 and 0.25. This is your x-axis and the corresponding y-axis. So if you observe, at 1 you have 0.013 and 1 again minus 0.013. So that distance you can see it here. So this is 0.1, 0.013, and 0.013. Both are not coinciding. Okay, because there should be one common point. So what you do, so you come to your Excel sheet and then make this negative. So both of them will meet at one common point now. And here the definition, or how they've defined the coordinates, is very less. So I've given you the other coordinate system. You practice in this, but know that in the exam point of view, you just have to make this modification. Now save this and go back to your solid edge, select your curve and then delete this. So there you have it, a closed loop. So now we'll again delete this curve and go to your main coordinate sheet and then come back to your propeller. So you have your first airfoil at this intersection. Okay, so this will be the chord length of this is 34. Yeah, 34 there. So here there is no deviation, so it is 34 and this is 34 too. Now go to your Excel, write a formula is equal to 34 multiplied by the first cell. You'll get your 34. Expand this to the next 3 cells so that the next ABC is also multiplied, and now expand it further down. You have your whole coordinate system. Now copy this and paste it here as values. Okay, don't do this because you'll get an error because there is equations involved. You are trying to multiply the same equations which you got the obtained answer from, so don't do that. Take your values. Okay, delete this, go to file, save as Propeller Hub. Importantly, what you need to save is depending on your office version, it should be workbook. The most preferred is Excel 97-2003 workbook. That will give you a format .xsl. So it will be like this. So .xsl. So that format can be easily read by Solid Edge. Any other format will not be read. So just make sure that it is in Excel 97-2003 workbook. Save it. And then come to your next coordinate. This is 34. And your next coordinate is again 34, but at a y distance of 69. So go here, modify this to 69, expand it throughout, file menu, save as again, AA section, save. You can use Ctrl Z option to modify it. Now that is done. Now we'll take 38, modify this to 38, enter, expand selection and then expand here. One thing we know, the distance here from center to here is 69 plus 50, so that is 119. Expand your selection, copy and paste values, delete, save as. BB, your section BB. And now the other section is 34 again. We have saved this file already, so we'll just leave it because this is 34, this is 34. Only changes is the length, so we'll come back to it again later on. So 20, next section is 20. Similarly expand, done. Now copy, paste values, and here it is 69, 50, 50, 50. So 69 plus 150 equals 69 plus 150. Expand it down, delete your values, save as. We've run C, we'll take D. Now D underscore D. I have doubt in the length, it is 69, 50, 50, 50. Okay, correct. Again, Control Z. Now the last one is 10. Expand your selection and then expand it furthermore. And then this is 69 plus 200, so it is 269. Control C, paste values, and you can delete this. Save as. Section E-E. Then go to open again. We'll take A or hub, anything works. So this distance is how much? 69, 50, 50. So 69 plus 100, it's 169. Expand your selection. Okay, I press Control S. Now change it, save as C-C. Done. So that is how you obtain all your coordinates. Now come back to your sketching, part design, surfacing, key point, curve by table, browse. First one is your hub. So hub, I think we didn't create for hub. Let us go there, main coordinates. So hub is 0 here, but everything else is same. File menu, save as hub. So once you've saved all of it, go to new, metal part, metric part. Now what you do, first go to your top view. Once you go to your top view, draw a line of 269 mm. Once you draw this line, take it an offset of 19 mm, and then click escape. You can delete your original line now. I'll tell you what the line does. Now you go to your surfacing, key point, curve by table, import all of your geometries, hub. Okay, finish. AA section, okay, finish. Curve by table, browse, BB, okay, and curve by table, CC, curve by table, DD, okay, and curve by table, EE. So all the airfoils have come. So here each airfoil is angled at 24, 8, 6, 4 and 2 degrees. Okay, so therefore the first airfoil, come to your front view and slightly bend it so that you'll be able to see your lines. So you are able to see your line. Okay, the significance of this line is the center of your 38 dia. Okay, so about that axis, this airfoils will be angled. Click on curves, switch off everything that you will not use for now. Go to home, select, click on the curve and bring it upon this curve, so such that it will face your side, and then turn it to 24 degrees. Done. Switch this off and switch this on. Again, press escape, click on the second curve, bring it to this point. Hub and AA has got the same angle. Okay, 24 degrees. It is not 0 and 24, so that will look very weird if you do that. And then next one, click on this, bring it to the center. Next is 8 degree. Turn it off. Press escape. Click on the curve. Bring it upon the line. And then turn it to 6 degrees. And then again, click on the curve. Bring it on the line, 4 degrees, turn it off, last line, click on the curve, bring it to the center, and then rotate it to, so you need to hold and rotate it to 2 degrees. Come to your front view, switch on everything, so you can see they have all rotated to their given dimensions. Okay, press escape, go to your home view. You can switch off this sketch. Now you need to switch off the sketch because while you're drawing your 3D extrusion, the line will come and interact. So now go to in sweep, go to loft, click on this corner, okay, this edge, and then here you'll observe a line going, so that is the path it is following to extrude. And then right click. Once you've connected all of it, you have your propeller blade. Go to your front view. It is like in the class how we saw propeller blade at different twist angle, and home, and done. Come to your top view, switch on the curve, and now come to the bottom, take circle by center. What we are trying to draw is, we're trying to draw this hub, which is 38 degrees, sorry, 38 mm. Circle by center, click on circle by center, and then take that point and draw for 38 mm, and done. Once you're done, exit your main window and then extrude. Click on this symmetric extrusion, right click, and then take symmetric and length as 20 mm, and done. Come to your top view. You can switch off the sketch, the line, or else you can delete it. Now that it is done, select and delete it. Now what you do is, you click on this protrusion here. Once you click on this protrusion, the pattern will get activated. So in this, choose circular pattern by center point. So this center point, the center point of this circle, make sure that you, 1 second, let's not delete the sketch because that will help to mark the center point easily. Okay, protrusion, circular pattern, and do this in top view. So here it will ask how many counts you need. So if you take 3 counts, it will give you a 3 blade. Okay, so just know that if I press enter, it will give you 3 blade. Just take 2 blades and enter. Then you have your other blade. Come out. Now you can select the sketch and delete it, and then go to your home view. You can turn off all the curves so that you can actually see, and turn off this PMI also, and even the base. Let me have base. So now you'll have to use your round option. Take upper part and give it a 5, and go to your bottom part and give it a 5, and then come to your blade intersection, give 1 here, and then go to your other blade intersection, give 1 here. So there is no specific dimension on how much the round should be. From my permutation and combinations, for a 5 and a 1 it is working. Okay, rest all it is intersecting or it is showing an error. So just follow this. Now take circle by center. So choose this circle, 16, enter, remove that excess circle. Now take extrude, negative, click on that one, through all, right click, so direction is downwards, and done. So this is your propeller blade.